Welcome students to this session on game theory. In this session we will be discussing about the principles of dominance or the dominance rule. In the previous session we have seen 2 into 2 games where saddle points did not exist. We applied analytical or arithmetic techniques or methods to find out the optimal strategies and the value of the game. Now what happens if there is a higher order matrix or a higher order game where the number of strategies available for both players A and B are more than 2? That is, if the payoff matrix is not a 2 into 2 matrix, it is say m into 2 or 2 into m, okay, or it is m into n, where m and n both are numbers greater than 2. Or in other words, if the payoff matrix is say 3 into 3 or 3 into 4, that is player A has strategies more than 2, similarly player B has strategies more than 2, then it becomes a higher order payoff matrix. So in that case, that analytical method, those analytical method or that arithmetic method which used in the previous session cannot be applied here. So for that, this higher order matrix should be reduced to a 2 into 2 matrix, so that this analytical rule can be applied or analytical method can be applied. So in this session we will see, if a higher order matrix is given to you, a higher order payoff matrix for a game is given to you where both the players have more than 2 number of strategies, can it be reduced to a 2 into 2 game so that both the players have 2 strategies each, so that the analytical or the arithmetic method can be applied to find the optimum strategies and the value of the game. So dominance rule or the principles of dominance gives you some guidelines on how to convert a particular higher order game into a 2 into 2 order matrix game. Let us see what is dominance rule, what are the conditions of the dominance rule, and how we apply dominance rule to specific problems to bring it down or to reduce it to a 2 into 2 matrix problem. Let us first discuss about the principles of dominance or the. Now from the player's A point of view, for player A, if each element in a row is less than or equal to the corresponding element in another row, that is in the payoff matrix, such a row can be deleted from the payoff matrix. So when we are seeing a higher order matrix of say suppose 3 into 3 matrix, player A has 3 strategies and player B also has 3 strategies, A1, A2 and A3, B1, B2 and B3 respectively. Now from the player A's point of view, since player A is trying to maximize his gains, or in other words is trying to we have seen that is interested in finding the maximum value. He first sees the minimum gains in each row and then finds the maximum of that. So minimum gain in each row for the and then the maximum amongst this is looking at. So see here from player A's point of view, maximum point, when if he wants to establish a maximum point, the maximum of the minimum gains, is looking at gains here. So for player A, if each element in a row is less than or equal to the corresponding element in another row, for example, if it's a 3 strategy A1, A2, A3, 3 strategies are available to player A, when I examine player A's first row, that is first strategy A1, if each element in A1 is less than or equal to the corresponding element in say another row, say of A2 or A3, so A1, all elements of A1 is less than or equal to all the corresponding elements of say strategy A2 in the payoff matrix, then I can say A2 dominates A1 because all the elements in A1 is less than or equal to the corresponding element in A2. So A2 dominates A1, or A1 becomes inferior to A2, hence A1 can be eliminated. That row which has the lesser elements, that particular row where each element in that particular row is less than or equal to the corresponding element in some other strategy or in another row, such a row can be eliminated. Similarly, from player B's point of view, it is other way around, because here player B is trying to minimize his maximum losses. That is, he is trying the minimax principle. That is, yes, of the maximum losses in each column, he is trying to minimize that. So for player B, if each element in a column is greater than or equal to the corresponding element in another column in the payoff matrix, such a column can be deleted from the payoff matrix. That is, for player B, if each element in a column, say that all the elements in, say, B1, column B1, are greater than or equal to the corresponding elements of column B2, then what happens here? B2 dominates B1 and B1 will be eliminated, because B1 has the greater elements. This is the other way around. If you are looking at it from the point of view of player A, each element in a row, if it is less than or equal to the corresponding element in another row, that particular row will be eliminated. Whereas for player B, here each element in a column is greater than or equal to the corresponding element in another column in the payoff matrix. Such a column where the elements are greater than or equal to the other, that will be deleted. So in both cases, what happens here is one of the columns or one of the rows will be eliminated, and in such way, after careful examination of each row and between rows and between columns individually, respectively, you can eliminate certain rows and columns and try to bring it into a 2 into 2 matrix. It may not be possible in all cases. Wherever possible, try to reduce the order of the matrix by applying this dominance rule. Now, in addition to these two, now sometimes direct dominance is not possible. Direct dominance in the sense these two conditions are not possible. In that case, you can even compare a row with other two rows and see if all the elements in a particular row are less than or equal to the average of the sum of the other two or the corresponding elements in the other two rows, then that lesser row, that inferior row, can be eliminated. Similarly, if I am talking about columns, if I compare a particular column with two other columns, if that column, say B1, if suppose I say B1, all the elements in B1 are greater than or equal to the average of the sum of the other two columns combined, B2 and B3 combined, then B1 can be eliminated. Okay, so that is how this dominance principle or the dominance rule works. Now, when we take a problem and solve this particular problem, we will understand it better. So let us take a problem and understand this dominance rule. Suppose this is the problem. Player A and player B. A has three strategies: A1, A2, and A3. B also has three strategies: B1, B2, and B3. The payoffs are given here. So all these positive values indicate gains to player A. So they are losses to B. Solve the above game. So we will apply the dominance rule here. But before applying dominance rule in any game theory problem, first find out whether there is a saddle point or not. So first we check for saddle point. You can see here the row minima here. 1 is the row minima for the first row. 2 is the minimum for A2, and again 2 is minimum for A3. Similarly, the maximum value for B1 is 6, the maximum value for B2 is 7, and the maximum value for B3 is 7. So the maximum value here is 2, maximum of this minimum is 2, the minimum of this maximum is 6, so 2 is not equal to 6, so maximum is not equal to minimax, hence saddle point does not exist. It's not a pure strategy problem. So now we have to apply mixed strategies, but before we can only apply analytical method or the arithmetic method which we applied in the previous session, that is the oddments, finding out the oddments and the probability values, only if it is a 2 into 2 matrix. Let us see now whether we can now find out whether it is possible for us to apply dominance rule and reduce this particular 3 into 3 matrix into a 2 into 2 matrix. Let us see whether we can apply dominance rule now, apply the principles of dominance to this particular case and find out whether we can reduce this 3 into 3 matrix. 3 into 3 here refers to the number of strategies. 3 into 3. Why it is called 3 into 3? Because player A has 3 strategies, player B also has 3 strategies originally. So it is a 3 into 3 matrix. Let us see whether we can convert it into a 2 into 2 matrix. Let us see, yes, it is now a 3 into 3 matrix. Now let us see, apply the dominance is possible. Let me see, dominance rule says examine each row. First we'll start with player A. Dominance rule always start with player A here. If I start with player A here, I'll first compare A1 and A2. I will first compare A1 and A2. Elements of A1. 1 is less than 6, but 7 is greater than 2. 1 is less than 6, but 7 is greater than 2. What does dominance rule says? All the elements in a particular row should be less than or equal to. This is not less nor equal to this corresponding element. 7 is greater than 2. So dominance rule cannot be applied between these two rows, A1 and A2. Yes, your first element here 1 is less than 6, fine. Second, 7 is greater than 2. So dominance rule cannot be applied. Now let me check between A1 and A3 now. A1 and A3. A1 and A3. A1 and A2, dominance rule cannot be applied because it cannot be reduced because 1 is less than 6, 7 is greater than 2. A1 and A3, let me check. 1 is less than 5, again 7 is greater than this 2. Again, not possible to compare them or apply dominance rule. Now what is left now? A2 and A3. A2 and A3. Let me check A2 and A3. 6 is less than 5. 6 is less than 5 here. 2 is equal to 2. 7 is equal to 6. So dominance rule can be applied. You can see very clearly. A3 and A2 if I compare, 5 is less than 6. 2 is equal to 2. 6 is less than 7. So according to the dominance rule, whichever row has elements less than or equal to all the corresponding elements of the other row, that will be cancelled. So in this case, A3 has all elements. You can see, check this way, all elements. 5 is less than 6, 2 is equal to 2, 6 is less than 7. So this particular row A3 is inferior. This is inferior to A2. You are doing a comparison between A2 and A3. So this is inferior to A2. So this particular row is eliminated. A2 dominates A3. Please note down. You can here the whatever we are discussing now, whatever logic we are discussing now based on the dominance rule is listed down here. But let us first understand how this comparison is done. A3 is eliminated because A2 dominates A3 and hence A3 becomes inferior. A3 is eliminated. So this particular row is completely eliminated. A3 is completely eliminated from the table. Applying dominance rule, we observe that all the elements of row 3 are less than or equal to all the corresponding elements of row 2. Hence strategy A3 is less attractive to player A. So A3 now is less attractive. He or she, player A, can straight away eliminate that, because even if it is there, it cannot become the optimal strategy. It cannot become the optimal strategy because all the elements here are less than or equal to the elements of the second strategy A2. See, this is less, 5 is less than 6, 2 is equal to 2, 6 is less than 7. So A3 is less attractive to player A and is considered inferior to strategy A2. So since A2 dominates A3, row 3 is eliminated completely. So you can now, one row of A3 is eliminated. So now the problem becomes a 2 into 3 problem, 2 into 3 matrix problem. 2 into 3 game. A has 2 strategies now, B has 3, because one of the strategies A3 of player A has been eliminated by dominance rule. You can see here A3 is eliminated. So this is your new payoff matrix. Only 2 strategies of A remain and 3 strategies of B remain. So it's a 2 into 3 matrix. So now again, let us compare now the columns now. Let us compare the columns B1, B2 and B3. B1, B2 and B3. Now if I compare B1 and B2 now, 1 is less than 7, 6 is greater than 2. So B1 and B2 you cannot apply dominance rule here. Now let me check between B2 and B3. 7 is greater than 2, 2 is less than 7. So again B2 and B3 cannot be compared. What is left is B1 and B3. 1 is less than 2, 6 is less than 7. I am comparing between B1 and B3. Comparing between B1 and B3 now. 1 is less than 2 and 6 is less than 7. So we can apply dominance rule here. Now according to the dominance rule, please be very attentive here, very clear. Unlike the strategy of player A here, player A, whichever row had the minimum elements, that was eliminated, correct? Those rows which had minimum elements or at least equal to elements and in comparison were eliminated. Here it is the other way around, because the higher value here, higher value for B here, these values of 2 and 7 are higher than this 1 and 6, which means this will give more losses to B than this particular row. So this B3 is cancelled, not B1 here. So in this case, column B3 will be eliminated because B3 has elements greater than or equal to the corresponding elements of B1. So applying dominance rule, we observe that all the elements of column 3, that is B3, are greater than or equal to all the corresponding elements of column 1. Hence, strategy B3 is less attractive to player B and is therefore considered inferior to strategy B1. So since B1 dominates B3, column 3 is eliminated completely. So as a result, this particular column is eliminated. So B3 is completely eliminated. So now your problem is now reduced to a 2 into 2 problem. A1 and A2 and B1 and B2 remain. Only A1 and A2, we can see here A1, A2, B1, B2 remain with the individual payoff matrix, whatever payoff matrix they have. So let us again check now. Now this becomes a 2 into 2 matrix now. This now becomes a 2 into 2 matrix. So now you can apply the analytical method. Before that, again let us have a small check, just to check. Let us see a small check to find out whether there is a saddle point or not. Because no, actually now you can first check here whether you get a saddle point or not. But here you will not get a saddle point. You can see here very clearly why. Because the minimum in this row is 1. You can see here the minimum in this row is 2 and the maximum amongst that is this 2. So the maximum value becomes 2. The maximum here is 6 and the maximum here in this column is 7 and the minimum of that is this 6. So this 2 is not equal to 6. So maximum is not equal to minimax. Hence saddle point does not exist. Saddle point does not exist. So we apply the analytical method. Analytical method can be applied here. This problem now is a 2 into 2 matrix here, and this now again reduces to the same problem, that 2 into 2 problem which we discussed in the previous session. It's almost the same. Whatever we discussed in the previous session, in one of the previous sessions, we discussed about a 2 into 2 problem without saddle point applying mixed strategies. It again reduces to the same here. Find out the oddments. You get oddments as 4 and 6. Similarly, oddments 5 and 5. So those who want to know more about finding out how to find these oddments can refer to the previous video, the immediately previous session which we have discussed about how to calculate the oddments and the probability values. Quickly, let us just again go through that. Here you can see the oddments here of A1 will be the difference between the elements of the second row. Similarly, the oddments of the second row will be the difference of the elements in the first row, and similarly for columns also. So you get oddment of A1 is 4, oddment of A2 is 6, oddment of B1 is 5 and oddment of B2 is 5. Similarly, you can find out the P1 and P2 values. The P1 and P2 values can be found out. The probability values can be found out. Let P1 and P2 be the probabilities with which player A uses strategy A1 and A2. So we will get the probabilities of 0.4 and 0.6. We will get the probabilities of 0.4 and 0.6. So how to, once the problem higher order matrix is reduced to a 2 into 2 matrix and there is no saddle point does not exist, then the procedure is similar to a mixed strategy problem using analytical method. Then it's the same procedure you have to follow. So here you get P1 is equal to 0.4, P2 is equal to 0.6, P1 is equal to 0.4 and P2 is equal to 0.6. Similarly, Q1 and Q2 you can find out, that also comes to around 0.5 and 0.5. Q1 is equal to 0.5, Q2 also 0.5. To find Q1 and Q2, Q1 is equal to 0.5, Q2 is also 0.5. So values of P1, P2, Q1, Q2, and then what is left? Now the 3 into 3 way of matrix is now reduced to 2 into 2 matrix by the application of dominance rule. So two strategies of A1 and two strategies of B2. You can see here the value of the game is also found out. Similarly, 1 into 2 minus 7 into 6 divided by 1 plus 2 minus 7 plus 6. So the value of the game comes to around 4, and the probabilities with which player A uses the optimal strategies here will be: the probability of player A using A1 is 0.4, the probability of player A using A2 is 0.6, and the probability of player A using A3 is 0, because A3 is not he or she is not using at all, because he or she has eliminated, the player has eliminated it using dominance rule. So the probability of player A using A3 is 0, but you have to mention it here. Okay. Probability of player A using A3 is 0. Similarly, the probability of player B using B3 is 0, because you can see here, now B3, originally B3 was there, but it is eliminated. So the probability of B using B3 is not there at all, it's 0. But the probability of B using B1 is 0.5. Similarly, the probability of player B using strategy B2 is again 0.5. B3, probability of B using B3 is 0. Similarly, the probability of A using A1 is 0.4, the probability of A using A2 is 0.6, and the probability of player A using strategy A3 is 0, and the value of the game is 4. So the game is loaded in favor of player A. Let us take another problem now. This is a 4 into 4 problem. 4 into 4 problem where there are 4 strategies of player A and 4 strategies of player B. Now, as usual, we will first find out whether there is a saddle point or not, finding out the maximin and the minimax values. You can see here the row minima here in this case is 2. You can see here all the minimum value of this row is 0. Of A2 it is 2. Here again A3 it is 0. A4 it is again 0, and the maximum amongst this is 2. So this is the maximin value. This is the maximin value. Similarly, if I consider the columns, the maximum in this particular column is 4, highest number is 4. Here it is again 4. Here also it is 4, and in this case it is 8, and the minimum of this is these 3 4s. So this also is included 4. 4 is the minimax value. 4 is the minimax value. This is also included in the minimax. Minimax value is 4. Maximin is 2. Minimax is 4. They are not equal, and saddle point does not exist. So you can now try to use analytical method. But to use analytical method, you have to reduce it into a 2 into 2 matrix. You have to do into a 2 into 2 matrix. We will discuss about the graphical method later. Let us not bring the graphical method now. That will be our next, in the next session we will be discussing about graphical method. So graphical method is applied when there is a case of 2 into m or m into n. Sometimes when you use dominance rule and reduce this higher order matrices, sometimes what happens, you can reduce it say to a 2 into n, 2 into m rather, 2 into m or 2 into n, that is player A has two strategies and B has more than two. So in that case you can solve that particular problem by graphical method and partly by analytical method. Or in other words, if it is say m into 2 or n into 2, more strategies, so more than two strategies of player A and two strategies of B, then also you can solve by graphical method. Any one of player A or player B, if they have two strategies and the other player has more than two, then you can solve such problems by graphical method. That we will discuss in the next session. Let us now concentrate or focus on dominance rule now. So this problem is a 4 into 4 matrix. Maximin is not equal to minimax. Saddle point does not exist. So mixed strategy can be applied. Let us use dominance rule and find out whether we can reduce this into a 2 into 2 matrix. Looking at this particular table, again applying dominance rule, we can see here all the elements of say A1 are less than or equal to all the elements of A3. Of course, you can compare one by one, A1, A2, A3. Wherever it is possible for you to apply dominance rule, you can apply. A1 and A2, if I see, you can see here 3, 3 equal, 2 is less than 4, but 4 is greater than 2. So A1, A2 comparison is not possible, cannot apply dominance. A1 and A3 if I use, 3 is less than 4, 2 is equal to 2 and 4 is also equal to 4, and this 0 is equal to this 0. So this element here 3 is less than 4, so A1 can be eliminated here because A3 dominates A1 because all the elements in A1 are less than or equal to the corresponding elements of A3. So A3 dominates A1 and hence A1 can be eliminated. So A3 dominates A1, hence A1 is eliminated. You can eliminate A1. A1 can be eliminated here. Yes, A1 can be eliminated. So matrix now reduces to 3 into 4 matrix. 3 strategies for player A and 4 strategies for player B. Now let us now look at player B. If I look at player B now, similarly I can, when after one by one comparison we can do, after we do that, we find out that B3 dominates B1 because every element of B1 here, say 3 is greater than 2, 4 is equal to 4 and 0 is equal to 0. So B1 here is inferior to B3 because higher elements here. So for B, higher elements not good. For B1 wants these elements, whichever elements are less in this way of matrix, that is a lesser loss to B. So he will prefer a lesser loss. He doesn't want his losses to be maximized. He doesn't want his losses to be, so he is looking at a minimax loss, minimax value of the loss. So this 3 here, higher value is eliminated. B1 is eliminated here because 3 is greater than 2, 4 is equal to 4, 0 is equal to 0. So when you are comparing B1 and B3, B3 dominates B1. So B1 is inferior here, hence B1 is eliminated. Hence B1 is eliminated. So again, your way of matrix now will now be a 3 into 3 matrix now. A1 is eliminated and also B1 is eliminated. So here 3 strategies of A are left, A2, A3, A4, and 3 strategies of B, B2, B3 and B4 are left. Now individually when I look at each one of this, it is not possible for me to now reduce this matrix further using direct dominance rule. Not possible. So now I should look at the third point of the dominance rule here, looking at the average. By examination, see now what I can do is if I go by the column or the row, anyone, if I go by the column or the row, if I go one by one, if I go by the column first here, in this case I can, comparing column B2 and the average of the column of B3 and B4, of 2 plus 4, average of these two. What I am doing now is the average of these two I am going to find, and then I am comparing it with this particular B, this particular strategy. 2 plus 4 is 6, 2 plus 4 is 6, the average of that is what? 3. 4 plus 0 is 4, the average of that is 2, and 0 plus 8 is 8, the average of that is 4. So you can see here 4 is greater than 3, 2 is equal to 2, and 4 is equal to 4. 4 is greater than 3, this 2 is equal to 2, and this 4 is, so let us, this 4 is greater than this 3, this 2 is equal to 2, and this 4 is equal to 4. So what happens, this particular column here, since this is from the point of view of B, is inferior to the average of B3 and B4, hence B2 can be eliminated. That's what it says. Neither a row or a column could be deleted based on individual comparison with the corresponding rows or column. By direct dominance rule, it is not possible now to reduce. So you are now comparing column B2 with the average of column B3 and B4. The elements of B2 are less attractive compared to the average of B3 and B4. Hence, we delete column B2 completely. So B2 is completely now eliminated. B2 is completely eliminated. We have to eliminate B2 completely. So now this particular pair matrix now becomes like this. B3 and B4 remain. Here A2, A3, A4 remain. Correct. Now again, we can do a comparison. You can see 2 is less than 4, but 4 is greater than 0. No further comparison is possible. Obvious it is. That's why we have taken average in the previous step. Let us examine the rows now. Let us examine the rows. If I examine the rows now, A2, compare A2 with the average of A3 and A4. When I combine these two, A3 and A4, if I combine these two, the average of this is 2. 4 plus 0 divided by 2 is 2. 0 plus 8 divided by 2. Average of these two is 4. Average of A3 and A4. 2 here and 4 here. This 2 is equal to this 2. This 4 is also equal to 4. So I can eliminate A2 now. It is not necessary any one of the elements should be less than that. Even if it is equal to, two rows have equal values of payoff. Equal values, corresponding elements are all same. Even then, to reduce it to 2 into 2 so that you can apply analytical method or the arithmetic method, you can eliminate any one of the rows. But in this case, you cannot eliminate A3 or A4 because it's the average. You cannot eliminate, so only thing is you can eliminate this A2 because all the elements in this particular row are less than or equal to the elements corresponding average values of A3, elements which are the average of A3 and A4. So comparing row A2 and the average of row A3 and A4, the elements of A2 are less attractive compared to the average of A3 and A4. When you take the average of A3 and A4 respective elements and compare it with A2, the condition of dominance satisfies because the elements in A2 are less than or equal to, in this case equal to the average values of the other two rows. So you eliminate this particular row, that is inferior. The average of A3, A4 dominate over A2. Hence delete row A2 completely. So what will happen now? Your final table or A3 and A4 being the strategies of player A and B3, B4 being the strategies of player B. We will find out whether there is a saddle point now. Since the maximum value is not equal to minimax here, saddle point does not exist because the maximum of this is 0, the minimum of these two values is 4, so maximum is not equal to minimax, hence saddle point does not exist. So since this is reduced to a 2 into 2 problem matrix, 2 into 2 matrix, we can apply the analytical or the arithmetic method. A3, A4, B3, B4, find out the oddments, and similarly find out the P3, P4 values. We have already seen the oddments of the first row here. The first row here is of strategy A3, second row is that of A4, first column is that of B3, second column is that of B4. So here the oddments are 8, oddment of A3 is 8, this 8 minus 0, which is written here, and similarly the oddment of A4 is 4 minus 0. These oddments, we have seen how to calculate these oddments, we have seen in the previous session. Now previous video we have seen how to find out these oddments. Similarly find out P3, P4 and Q3, Q4 values for strategies A3, A4 and B3, B4 respectively. Let P3 and P4 be the probability. A uses strategy A3 and A4 respectively. A's oddments will be the difference of the two elements of row 2 ignoring the sign. Similarly, A1's oddment will be the difference of the two elements of row 2 ignoring the sign. Similarly, this particular strategy, you have to be very careful here. When I say the first row here, it corresponds now to the whatever strategy is left now, because it's a reduced 2 into 2 matrix. So this first row will be pertaining to A3. So the oddment of A3 is 8 and the oddment of A4 is 4. Oddment of A3 here is 8 and oddment of A4 is 4. Similarly, P3 and P4 you have to find out for A3 and A4 respectively. The same thing holds good for B. Q3 and Q4 will be the probabilities with which player B uses strategy B3 and B4 respectively. B's oddment will be, or B3's oddment will be 8 minus 0, which is 8. B4's oddment will be 4 minus 0 is 4, and Q3 and Q4 can be found out by this particular expression. Is all similar to how you have calculated previously. So once this higher order matrix by dominance rule is converted into a 2 into 2 matrix, the procedure is same as you have done in a mixed strategy problem. 2 into 2 matrix mixed strategy problem, which we have discussed in the previous video. So previous session we have discussed all these things. So same way you find out now, because now it is convert this particular 3 into 3 matrix or 4 into 4 matrix is now converted into a 2 into 2 matrix or reduced to a 2 into 2 matrix now using dominance rule. You can straight away apply the 2 into 2 mixed strategy procedure. Value of the game, again 4 into 8 minus 0 into 0 divided by 4 plus 8 minus 0 plus 0. That will be 32 by 12, that is 2.67, and the probabilities with which player A will use this optimal strategies are: for A1 probability is 0 because A1 is eliminated, A2 probability is 0 because A2 is also eliminated, for A3 the probability is 0.67, and for A4 the probability is 0.33. So player A will be using strategy A3 67% of the time, and player A will be using strategy A4 33% of the time. And similarly for player B, B1 and B2 probabilities are 0 because they are eliminated. So B will be exercising or using strategy B3 67% of the time and B4 33% of the time. And the value of the game is 2.67. It's a positive value, which means the game under consideration is loaded in favor of player A because it's a positive value. So the game is loaded in favor of player A. So that is about dominance rule. So we apply dominance rule and reduce it to 2 into 2 matrix wherever possible, and then apply this mixed strategy. Now in case sometimes by applying dominance rule you can only reduce the entire payoff matrix, higher order payoff matrix, say into a 2 into n matrix. 2 into sense strategy A has two strategies, player A has two strategies and B has more than two strategies, and it is not possible to reduce it further, then you can apply graphical method. Similarly, if it is a n into 2 problem, that is player A has more than two strategies and B has two strategies, and it cannot be reduced further into a 2 into 2 matrix, and graphical method can be applied. So in our next session, in our next video, we will be discussing about how games can be solved by graphical method when it is a 2 into m problem or a n into 2 problem. So that will be our topic for the next video. Thank you, students.